Today we're going to do a throwback to Unit 3, which was all about factoring. Well, today's lesson is all about solving equations by factoring. So we are going to do just a quick review of factoring. With part A here, the first thing that I want you to always look for when you factor is a greatest common factor. So I don't have a greatest common factor. So then I'm going to just multiply my first and my last term, 9p squared. And I'm going to try, my job is to find two numbers that multiply to 9 and add to negative 10. Well, and I could say, okay, well that's negative 9 and negative 1, and they both have p, so it gets to p times p is p squared. And in this case, a equals 1, meaning I do not have a coefficient in front of my squared term. When that happens, we use our little factoring shortcut, which is real nice. So I go p, and I'm just going to take my number minus 9, and the other one becomes minus 1. So we get p minus 9 and p minus 1. And that's how we factor it. Part B over here, I'm going to do the same thing. First thing I look for is a greatest common factor. I see everything is divisible by 2. So we factor out the 2 first, and now I go divide everything by 2. I get b squared minus 6b minus 27. And so now I'm going to factor everything on the inside of the parentheses. So I'm going to say what multiplies to negative 27 but adds to negative 6. Well, I know 9 times 3 is 27, and I know it has to be negative 9 because negative 9 plus 3 gets me the negative 6. And once again, because now I do not have a coefficient in front of my squared term in that parentheses, this 2 is just going to carry down. And now I can do b minus 9 and b plus 3. Okay. With part C, you could recognize this as a difference of squares, or what we could do is I notice that I'm missing my middle term. So I could put in a 0 and then it's the same thing. What multiplies to negative 81 but adds to 0? That's 9 and negative 9. And once again, I do not have a coefficient in front of my squared term. So you know I'm going to have n plus 9 and n minus 9. You could have also recognized this as a difference of squares and just done our little square root thing. You're going to get the same thing. Okay, part D, I do not have a greatest common factor. So I can multiply and say, okay, what multiplies to negative 18x squared but adds to negative 17? Well, that's going to be a negative 18x and 1x. And because this time I do have a coefficient in front of my squared term, that just means I can't use my nifty little shortcut we've been using. So what we're going to do is we're going to substitute this negative 18x and the 1x in for the negative 17x. So I'm going to go 2x squared minus 18x plus 1x minus 9. So you see how I just substituted this for the stuff in the middle. So now we're going to cut this in half. We're going to look for the greatest common factor of each side. So the GCF of the left side I see is a 2, but also they both have x, so it's 2x. When I divide each of those by 2x, I get x minus 9. The right side, well, it doesn't have a greatest common factor, and so in this case we're just going to pull it out a 1, a positive 1, and when that happens I'm left with x minus 9. Your goal when you do this is that these two parentheses have to match. If they match, you've done it correctly, and if they don't, you need to go back and check your work. Because now what's happening is that we can factor out that x minus 9 from both of those. So if I factor out x minus 9 from both of those terms, what we were left over with was a 2x plus 1. So there was a very quick review of factoring. And if you have questions about factoring, I would suggest you go back and review any of the videos or notes from Unit 3. So how does this help us to solve an equation? Well, let's take a look. We're going to talk about something called the zero product property. And basically, here's what we got. Part A, 3x equals 0. Well, what does x equal? Well, I know, well, x equals 0. Three times 0 equals 0. Okay, yeah, that's the thing about 0, like 0 times anything gets a 0, right? So if I have 3 times x plus 1 equals 0, well, this time, 3, even if I was to divide both sides by 3, the x plus 1 equals 0. What does x have to equal? If I subtract 1, I know that x equals -1. And so we know that x equals -1. Solve that through algebra. And instead of having to do the full algebra step every time like we did, here's what I want you to see. Well, I want you to know the zero product property. The zero product property, product means multiplication in math. So basically this says that if two things multiply to be 0, so I'm going to write it as a times b equals 0. So if a times b equals 0, then either a equals 0 or b equals 0. Here's another way of saying that. If two things multiply to be 0, one of those things must be 0. So once again, why does this apply to factoring? Well, here's what I want you to see. Even just with example B here, I have 3 times x plus 1 equals 0. That's an application of the zero product property. 3 times something, meaning two things multiply to get 0, I know one of those had to be 0. And we knew it couldn't be 3 because 3 is 3. 3 is not 0. So I knew that x plus 1 had to be 0, and we could solve it from there. So if we can break down an equation into its factors meaning two things multiplied together, then we can use the zero product property right there and apply it to get to our solution. So let's look at this with example 2. So if I'm going to factor this, and we factored this before, two numbers that multiply to 9 but get us to -10, we knew that was -9 and -1. And because a equals 1, meaning I do not have a coefficient in front of the square term, I can just say p minus 9 and p minus 1. But notice this is an equation, so this time it equals 0. Well, hey, look at that. I have two things that multiply to equal 0. And the zero product property says if two things multiply to be 0, then one of those things has to be 0. So I know that either p minus 9 has to equal 0 or p minus 1 has to be 0. Well, then I can just solve for p in each of those to get p equals 9 or p equals 1. And isn't that so much faster than quadratic formula or completing the square? This is why we like solving by factoring. I could do the same thing on part B. Once again, I see this is a difference of squares. Or you can just, why am I doing it over there? Okay, let's try that again. You could substitute in 0 in the middle there. What multiplies to -81? but adds to 0. Well, it's positive 9 and negative 9. Because I do not have a coefficient here in front of the square term, we could just use our little shortcut, meaning that I get n plus 9, which we got from right there, and n minus 9 equals 0. Hey, I have two things that multiply to be 0. So the zero product property says that one of those things has to be 0. So I can subtract 9 and I get n equals negative 9 or n equals positive 9. And those are my solutions. So here's your big idea of factoring, of solving behind factoring. Factor the equation then set each factor equal to 0 and solve for the variable. And that's all we have to do.